The dark web's new deadliest drug. A lab-made opioid, reported to be dozens of times stronger than fentanyl. Cheap to synthesize, easy to ship, hard to trace. Encrypted markets move micrograms in plain packages. Vendors vanish. Accounts respawn. Money blurs through mixers. Across Europe, sudden clusters hit emergency rooms. Medics report rapid collapse and difficult reversals. Forensic labs are finding novel analogues before alerts catch up. The supply chain runs from clandestine synth to street pills and vapes. Incidents trend upward, fast. Investigators race to map networks before the next wave. But to understand the threat, we have to look closer. This isn't a drug grown in a field. It's born in a lab, designed for maximum impact with minimal material. These are the nitazines, a class of synthetic opioids first developed in the 1950s as potential pain relievers. They were shelved, deemed too potent, too dangerous for clinical use. Now, 6 decades later, their chemical blueprints have been resurrected from obscure scientific journals and unleashed onto the dark web. The synthesis process is deceptively simple, requiring precursors that are often unregulated and easily purchased from online chemical suppliers. For a clandestine chemist, this is the perfect storm. Unlike fentanyl, which has a few well-known production pathways, nitazines can be tweaked and altered. A minor change to the molecule, swapping one atom for another, creates a new analog. A substance that is technically legal until it's individually banned. This creates a deadly game of cat and mouse. Forensic labs identify a new compound, governments move to schedule it, but by the time the ink is dry on the legislation, the chemists have already moved on to the next variation. Each new analog has a slightly different potency, a different effect profile. Some are reported to be 10, 20, even 40 times stronger than fentanyl, itself a substance 50 times more potent than heroin. We're dealing with compounds so powerful that a few grains, the size of a pinch of salt, can be a lethal dose. This isn't just a drug, it's a chemical weapon in powdered form, and its battlefield is the global supply chain. How does a substance this dangerous travel from a hidden lab to a user's doorstep? It hides in plain sight. The sheer potency of nitazines is a logistical advantage for traffickers. A kilogram of pure product, enough for millions of lethal doses, can be shipped in a small, unassuming package. It can be disguised as a cosmetic sample, a research chemical, or a food supplement. Customs and border agencies are overwhelmed. They rely on intelligence, on profiling, on canine units. But dogs can't be trained to detect a substance that has a dozen different forms and no consistent scent. X-ray machines can't distinguish a few grams of white powder from countless other legitimate shipments. The needle isn't just in a haystack, it's in a mountain of identical needles. The distribution network is decentralized and resilient. It operates on the dark web, through encrypted messaging apps, and on niche forums. A vendor in one country can sell to a customer in another, with payment made in untraceable cryptocurrency. The package is then drop-shipped from a third country, completely disconnecting the seller from the physical product. If one vendor is shut down, their listings are mirrored by a dozen others within hours. The system has no single point of failure. It's a ghost in the machine, a global anonymized network that turns the international postal system into an unwitting drug mule. And the final stop on this journey is where the real danger multiplies. The call comes in as a standard overdose. But when first responders arrive, the scene is different. The victim went down too fast. The usual signs are there, but they're amplified, accelerated. This is the new reality for paramedics and emergency room doctors across Europe and North America. They are on the front line of a chemical arms race they didn't know they were fighting. The standard tool for reversing an opioid overdose is naloxone. It works by knocking opioids off the brain's receptors, restoring the drive to breathe. But nitazines are different. They bind to those receptors with incredible tenacity. A single dose of naloxone, or even 2, is often not enough. Medics report using 3, 4, sometimes entire kits on a single patient, fighting a desperate battle against a substance that won't let go. Some patients experience a rigid locked chest syndrome, making it physically impossible to administer rescue breaths. The danger is compounded by ignorance. The user often has no idea they're taking a nitazene. They think they're buying heroin, or a counterfeit oxycodone pill, or even cocaine. The nitazene is mixed in as a cheap, potent adulterant. This creates unpredictable hotspots in the supply. One pill from a batch might have a tiny amount, while the next contains a lethal dose. For the user, it's Russian roulette with every purchase. For the medics, it's a mystery they have to solve in minutes before a life is lost. They are fighting an invisible enemy, and they're running out of ammunition. How do you fight a threat that is everywhere and nowhere at once? You fight it on its own turf, the digital world. Law enforcement and intelligence agencies are deploying a new arsenal of weapons. They're not battering rams and bulletproof vests. They're algorithms and data crawlers. Teams at agencies like Europol and the DEA are running a digital dragnet, scraping dark web markets, infiltrating encrypted chat groups, and analyzing blockchain transactions. They use AI to identify the linguistic fingerprints of major vendors, even as they change usernames and platforms. They follow the money, using advanced forensic tools to de-anonymize cryptocurrency mixers, linking wallets to real-world exchanges and identities. It's a painstaking process. Every successful takedown provides a new piece of the puzzle: a shipping address, a precursor supplier, a new chemical formula. This intelligence is then fed into public health systems. Scientists are now using wastewater epidemiology, testing sewage to detect the presence of new nitazene analogs in a community before the overdoses begin. It's a citywide urine test, providing an early warning that can be used to target public health alerts and distribute naloxone. This is the new paradigm, a fusion of cybercrime investigation, forensic chemistry, and public health. It's a race against time, a constant battle of innovation between those who create the poison and those who try to contain it. The network is vast, the enemy is adaptable, and the stakes could not be higher. The next wave is already forming. Micrograms, not milligrams, that's the scale that changes everything. Cut to a 1950s lab bench. Researchers chase a new kind of painkiller, benzimidazole opioids, now called nitazenes. They're never approved, too potent, too risky. Their blueprints are filed away, until the internet brings them back. Here's why they're so dangerous. Opioids work by binding to mu opioid receptors in the brainstem, the switches that slow breathing. Nitazenes bind hard and act strong. High affinity, high efficacy. Translation: a tiny amount flips those switches fully. Potency comparison: heroin, structure 1x, fentanyl 50x, certain nitazenes 500, 2000x plus. Micrograms matter because the margin of error disappears. At this scale, the line between effect and overdose is a hair's breadth. Street mixing can't hit that precision. One pill gets traces, the next, a fatal spike. 0.0004 G. 0.4 mg, lethal range. Now, reversals. Naloxone kicks opioids off receptors, but with nitazenes you're fighting both grip and duration. The drug's strong binding can outcompete a single naloxone dose. As it redistributes in the body, more can rebound onto receptors. Multiple naloxone doses often required. Clinically, that means stacked doses, tight monitoring, and ventilation support. Seconds count. Back to the pipeline. Unlike plant-based drugs, these start as recipes: unregulated precursors, simple glassware, and a tweakable core molecule. Swap a substituent. New analog, same threat, legally grey until scheduled. Analog drift. Rapid variant turnover. That chemistry, married to digital distribution, scales globally. Micrograms ship as research chemicals, move through mixers, and land on doorsteps, fast. We're not just chasing dealers, we're chasing design. To counter it, we need to see the molecule, predict the analogs, and outpace the next variant, before micrograms become morgue stats. Old supply chain? Cartel broker smuggler street, slow, leaky. New chain? Manufacturer platform user, flattened. Encrypted chat storefront UI's burner handles. Orders placed in minutes, paid in crypto, cleared by bots. Microparcel economics. 1 gram becomes hundreds of letter-sized shipments, each package small, cheap, fast. At scale, noise looks like normal mail. Dropship tactics. Reships. Fragment the trail. Maker never meets buyer. Intermediaries only see their slice. Labels here. A mailbox there. Then the conversion. Mixing labs. Pill presses. Turn powders into lookalike meds. Stamps. Colors. Blister packs. False signals of safety. Branding multiplies demand. Consistency keeps customers returning. Ultra-potent synthetics. A logo can mask a lethal dose. Law enforcement challenge. Speed. Spread. Millions of tiny parcels. Cross-border in days. Jurisdictions don't sync. Platforms morph and migrate. Seizures hit spokes, not the hub. Map lines blinking worldwide. The pipeline is digital. The product is molecular. The margin for error is micrograms. Seconds and safeguards decide outcomes. ER corridors tell the story first. A quiet week becomes a cluster. Paramedics radio in unresponsive shallow breathing pinpoint pupils. Again. 1 reversal isn't enough. 2, 3 naloxone doses to bring a pulse back. Then the next call. Lower third. Sudden overdose clusters. Repeated naloxone dosing reported. Source. Regional EMS bulletins. At intake, patterns blur. Not just people who use opioids. Partygoers, students, shift workers, pain patients, non-traditional users. Same collapse. Different backstories, same chemistry. In the tox lab, the screens light up, then stall. Routine panels miss the newest analogs. The molecule has drifted a few atoms. The test still speaks last year's language. Samples ship out for specialized confirmation. Answers arrive days later. Lower third. Standard hospital screens may not detect emerging synthetics. Source. National Tox Networks. Dashboards lag behind the stretchers. Advisories wait for scheduling. Legal listings trail the marketplace by a quarter beat. Lower third. Scheduling and alerts delayed across jurisdictions. Source. Public health advisories, case studies map the pressure. Northern Port City. Weekend spike tied to counterfeit pain pills. Multiple naloxone redoses. No opioid history in half the cases. University Town. Party scene turns. Stimulant users crash with opioid tox signs. Unexpected cross-contamination. Border region. Postal hub seizures rise, but hospital flags outpace notices. Headline. Hospitals see unusual overdose clusters. Headline. Labs warn of undetected analogs. Headline. Advisories trail street reality. On the big map, hotspots flicker, migrate, dim, then reignite. Platforms morph. Parcels move. By the time a name is listed, a variant is already in circulation. Lower third. Trend. Faster spread. Wider demographics. Shifting hotspots. Source. European Surveillance Consortia. Back in the ER. Seconds and safeguards still decide outcomes. Frontline teams adapt in real time. The rulebook updates after the shift ends. If you didn't get it from a pharmacy with your name on it, don't trust it. Unknown pills and powders can contain ultra-potent synthetics. If legal where you live, use test strips. Test a small sample. Follow the strip's instructions exactly. Remember, a negative does not guarantee safety. Never use alone. If you can, have someone sober nearby who can call for help. If that's not possible, use a check-in line or digital timer so someone knows to reach you if you don't respond. Know the signs of an opioid overdose. Unresponsive or won't wake up. Slow or no breathing. Blue or gray lips or fingertips. Pinpoint pupils. Gurgling or snoring sounds. If you see these signs, call emergency services immediately. Give rescue breaths if trained. Tilt head back, lift chin. 1 breath every 5-6 seconds. Administer naloxone. Naloxone basics, nasal spray, peel. Place the tip in one nostril. Press the plunger once. If no response in 2 to 3 minutes, give a second dose. Keep giving a new dose every 2 to 3 minutes if breathing doesn't improve. If you only have injectable naloxone, Follow the device's instructions. Inject into the outer thigh through clothing if needed. Stay until help arrives. If the person starts breathing, place them on their side in the recovery position. They may wake disoriented. Reassure them, more help is on the way. Store and share safety. Keep naloxone on you and where others can find it. Check expiration dates. Store medications and substances locked and labeled, away from children and pets. Avoid mixing opioids with alcohol or benzodiazepines. This dramatically increases overdose risk. Tell friends and family where naloxone is and how to use it. Share only verified alerts from health departments, hospitals, and poison centers. Avoid rumors and screenshots without sources. Small choices buy time. Time saves lives. Carry naloxone. Learn the signs. Call for help early. Test if legal. Look out for each other. In an emergency, call 911 or your local emergency number. Naloxone and local training. Check your health department or pharmacy. Substance use support. SAMHSA National Helpline, US. 1-800-662-HELP 4357. Or your national helpline. Poison Help. 1-800-222-1222. US. Or local poison center. Verified updates. Local public health websites and hospital advisories.